Hi everyone, in this video I'm going to go over the answers to the review problems on probability. If you just want to know the answers, they're on the screen at the moment, and you can pause the video to just check over your work, or you can wait a moment and I'll get into the explanations for each problem. Okay, question 1. All the problems in question 1 deal with a well-shuffled deck of 52 cards. Part A asks, what's the probability of drawing a king or a queen? Well, in a deck of 52 cards, there are 4 kings and 4 queens. So for a total of 8 cards, that would result in a king or a queen. So the probability of getting a king or a queen is 8 over 52. And we can reduce that to 2 over 13. What's the probability of drawing an ace, or a card that's less than 5? Well, the deck has 4 aces, and the cards that are less than 5 are the 4s, the 3s, and the 2s. Remember, there are no 1s in the deck, and there are 4 of each of those cards. So there are a total of 16 cards that meet this condition out of 52, so the probability is 4 over 13. Part C asks us the probability of getting a red jack or a black king. The deck has 2 red jacks, those are the hearts and the diamonds as the red cards, and there are 2 black kings, those are the spades and the clubs. So the probability here is 4 out of 52, which reduces to 1 over 13. What's the probability that the card drawn is a face card or a prime number? Well, the deck has 12 face cards. Those are the 4 jacks, 4 queens, and 4 kings. And then the prime numbers we're interested in are the 2s, the 3s, the 5s, and the 7s. And there are 4 2s, 4 3s, 4 5s, 4 7s. Adding all of these up, that's a total of 28 cards, I believe, out of the 52 that could be drawn, and this can be reduced to 7 over 13. Next part, what's the probability that you draw a diamond or a queen? Diamond is one of the suits, and there are 13 cards of each suit, so 13 diamonds. Now, there technically are 4 queens, but we actually already counted one of the queens in this diamond. One of the queens is the queen of diamonds. So really, if we don't count the queen of diamonds, there are 3 other queens left in the deck. So that's only a total of 16 cards out of 52, which reduces down to 4 over 13. Be very careful in these problems where the 2 types of cards they talk about overlap. Okay, so one of the queen is a diamond. So another example is, what's the probability of drawing a heart or a red jack? Well, just like diamonds, there are 13 hearts. Now, one of those hearts is the jack of hearts, which is actually a red jack. So there's only one other red jack, and that's the jack of diamonds. So here we only have a total of 14 cards out of 52. This can be reduced to 7 over 26. Finally, for these card problems, what's the probability of drawing a spade, a club, or something that's less than 8? Okay, 13 spades out there, 13 clubs out there. And what are the numbers less than 8? Well, we have the 7s, 6s, the 5s, the 4s, the 3s, and the 2s. Now, for each of these, though, 2 of them are already counted in the spades and the clubs. Okay, so there are 2 black 7s, 2 black 6s, 2 black 5s, 4s, 3s, and 2s. So really, we only need to count the red ones that are left. and there's only two red 7s, two red 6s, all the way down to two red 2s that we have to consider. Adding all of these up, I think what we get is a total of 38 cards out of 52, which we can reduce to 19/26. Okay, question number 2 involves a spinner with 10 spaces numbered 1 through 10. What's the probability of spinning an odd number or a power of 3? Since this set of outcomes is actually small, I can actually write them out. So an odd number is something like 1, 3, 5, 7, and 9. And a power of 3, well, that's like 3 to the first, which is 3, 3 to the second, which is 9, 3 to the third is 27, which isn't possible on the spinner. So actually there are only 5 outcomes here out of the 10 possible. So the probability is 1/2. What's the probability of spinning an even number, or a multiple of 4? Well, even numbers, 2, 4, 6, 8, and 10. The multiples of 4 are already in the set, 4 and 8. 12 is not possible. So, kind of similar to the first one, the probability is 5/10, which can be reduced to 1/2. What's the probability that the number spun is less than 8 or divisible by 8? Well, the numbers that are less than 8 are 1, 2, 3, 4, 5, 6, and 7. And there's one number between 1 and 10 that's actually divisible by 8, and that's 8. So there are 8 outcomes here out of the 10 possible, and the probability can be reduced to 4/5. In question 3, we roll 2 dice. Part A asks us how many outcomes are there. By the counting principle, the first die has 6 outcomes. The second die has 6 outcomes. Together, when they're rolled, they have 6 times 6, or 36 outcomes. Part B asks us how many of these outcomes result in a sum of 3. Well, we could roll a 1 on the first die and a 2 on the second die, or a 2 on the first die and a 1 on the second die. And those are the only ways we can get 3. So the answer here, there are 2 outcomes, 2 ways to roll a 3. Okay, since 0 is not on, we can't really write 3 and 0. How many ways are there to get a sum of 9? Well, making a list, we can roll a 6 and a 3. We can roll a 5 and a 4. We can roll a 4 on the first die and a 5 on the second die. Okay, these two are different outcomes. Or we can roll a 3 on the first die and a 6 on the second die. So counting those up, that seems like there are 4 possible outcomes. Number 3, parts D and E asks us for the most likely and the least likely outcomes. An easy way to see what the most likely outcomes and the least likely outcomes are to make this table that I have here on the right. We can think of over the top, across the top here, these are the results for the first die, and along the side here, these are the results for the second die. And inside the table I've written down what the sums would be. So if I roll a 3 on the first die and a 1 on the second die, the sum is 4. The most likely outcome is going to be the one that occurs the most in this table, and that's actually this little diagonal row of 7s here. Okay, there are 6 ways to get a 7, and fewer ways to get any of the other numbers. So the most likely outcome when you roll 2 dice is actually 7. What are the least likely outcomes? Well, from this table we can see there's only one way to get a 2, and there's only one way to get a 12, and that's if you get double 1 or double 6s. So the least likely outcomes, there's actually a tie for them, are 2 and 12. Finally, question number 4 asks us how many numbers between 1,000 and 999 have distinct digits. Well, let's apply the counting principle here. So there are 4 digits that we need to fill in. So the first digit in a 4-digit number can be any number from 1 to 9. Okay, it can't be 0. We can't lead off a 4-digit number with 0. So there are 9 possible choices there. Now, for the second digit, we throw in the 0, okay, because the second digit of a 4-digit number can be 0, but we remove one of the numbers that we chose first. So we could fill in with any digit 0 to 9, except what we chose in the first place. So that's a total of 9 digits. Okay, 0 to 9, 10 possibilities, except the one we chose first. Okay, so down to 9. And then here we can choose any number 0 to 9 except the number that we picked in the second place or the first place. So now we're down to 8 possibilities. And then in the last one, 0 to 9, except any of the 3 previous ones. So now we only have 7 possibilities. By the counting principle, the total number of possibilities are 9 times 9 times 8 times 7. Just doing a little multiplication, 81 times 8 times 7. 81 times 8 is 648 times 7, and that gives us 4,536 numbers with distinct digits between 1,000 and 9,999.